Hi, I'm Mr. Z.
Art with Mr. Z.
We're going to be learning about technical drawing. Technical drawing is a kind of drawing where you can draw something and then give that drawing to somebody else, and they're able to read that drawing in a way that allows them to make that thing that you drew. Alternately, if you are able to make technical drawings, you are also able to read technical drawings, which means that if somebody draws a technical drawing, gives it to you, you will be able to make something for them based on what they drew. This is a really good collaborative tool because it allows you to work with lots of different people in order to manufacture, fabricate, or otherwise produce or create things. Normally, we would be doing technical drawing on a drafting table like this one. However, my document camera will slide all the way down if I put it up here, so I'm going to be doing my demos on the table. In order to make a technical drawing, you're going to need four things. You're going to need a piece of paper, you're going to need a ruler, you're going to need an eraser, and you're going to need a pencil. In order to make technical drawings really simple to read and consistent, so that that also adds to their simplicity and ease of readability, we need to kind of format them in a way that is the same every single time. That way, somebody who's looking at a technical drawing knows exactly what to look for when they read it. And I want you to get into the habit of doing this too. So with your ruler, you're going to always kind of set your drawing up in the same way. I'm not going to be as strict about the orientation, but I do want you to always use a ruler or straight edge in order to make your lines nice and straight and easy to read. The first thing you want to do is look at your ruler carefully to make sure that the end lines up with the zero. Some rulers, you'll have a little bit of ruler before you get to the zero, and you want to be aware of that because it's going to help with your measurements. The first thing I want you to do is to measure a border along the outside of your page. For me, it's going to be a 1/2 inch border because I'm using an 8.5 by 11 inch sheet of paper. So in order to do that, I want to be consistent. So I'm always starting from the left edge, and I'm making a little mark here, a 1/2 inch in from the edge, and I'm lining the zero up with that edge. So you want to make sure that you know where the zero is on your ruler. I want to come down and do the same thing here. Make sure that's a 1/2 inch. Okay? That way, when I go to draw the line between these 2 points, it will be perfectly parallel to the edge of my paper. And I did a fairly light line here, and that's okay. You also want to do a mark a 1/2 inch from the right edge of your paper. 1/2 inch and a 1/2 inch. And then you're going to connect those two with a nice light line. Then I want you to come in and bring a 1/2 inch border from the top and bottom of your paper as well. There's a mark. There's a mark. You always want to make a little measurement mark before you draw the line. 1/2 inch and a 1/2 inch. And then you just connect the lines. This ruler is a little bit broken near the 11 mark, so I'm going to turn it around and use the metric end just for my straight lines. And if you do not have a ruler, I will post a link that I made to a demo on how to create your own ruler and straight edge. Straight edges, of course, can be anything that has a long enough edge that's straight and hard enough for you to draw a straight line against. And rulers have to be made from something that you know is a definite unit of measurement. Right now, I am going to go ahead and block out a section of this to be my title area. There is an official term for this in technical drawing that we're not going to get into. I'm going to give myself another 1/2 inch over here and a 1/2 inch over here. Normally in technical drawing, you'd be using a lot more tools than just a straight edge and a pencil. You'd also be using different kinds of triangles, compasses, and templates in order to create different angled and curved lines. So
At this point, I have a drawing that's set up with a title bar, the drawing area, and a border. Right now, I've taken about 2 minutes to do all this stuff. Up here, what I want to do is kind of just put my ruler in there somewhere, and I want to draw 2 parallel lines. In here, I'm going to put some information that tells you what you're going to be looking at in the drawing. These parallel lines that I just drew very lightly, I didn't use a lot of pressure to draw them. That's where I'm going to write my text. Those are called guidelines. I eyeballed it. You should feel free to measure your guidelines and make your text about 1/8 of an inch high. If you look at the measurements on your ruler, you'll see that they're divided into as many as 16 or 32 different marks per inch. So you have the 1/2 inch, the 1/4 inch, the 1/8 inch, and the 16th inch. And generally when you make text, you want it to be about 1/8 of an inch high. That is a good size readability. Text should always be in all caps, all capital letters, when you are writing in a technical drawing. So the first thing I'm going to write is my name. And I'm writing those letters between those parallel lines. It's nice and clear, it's in all capital letters so that anybody could read this very easily. And then I'm going to skip some space and I'm going to write what this is. And then I'm going to skip a little bit more space and I'm going to write today's date. You can write the date in whatever format works for you, as long as it's obvious what the actual date is. Because we're in the earlier months, I like to specify what's the month and what's the day, because if I just wrote 4/5/21 or something, it could also be the, if I just wrote 3/5/21, it could be the 3rd of May if you're from the right place. So I like to be very clear so that anybody around the world who looks at this drawing would know what the date is, even if they don't live in a country where they use month, day, year to express the date. The next thing I'm going to do is I'm going to have been given an isometric drawing in this corner. An isometric drawing is sort of like a drawing that looks like it's in 3D. You're not going to have to draw an isometric during this evening. I'm only going to ask you to draw the other views. So the way it works is, the isometric drawing is going to look something like this. I'm going to draw it really quickly for you. That's the isometric view. Notice how it looks kind of three-dimensional. By looking at it, you get a sense of the depth, width, and height of this object. You get a sense of what it looks like, or what it would look like if it was really in front of you. An isometric view does not use perspective, the way that you learned earlier this year, where all the lines recede toward vanishing points. Isometric views present objects as if they continue on forever in the same dimensions. So, for example, this is 1 inch, and this is 1 inch. If this were in perspective, this would be getting slightly smaller here compared to this edge, because it would be farther away from us. Usually, your isometric view will be presented with what are called dimensions. Dimensions, or dimensions, tell you how big each part of the drawing should be. I'm going to put them in now. By looking at the dimensions, we can see that this side of the object is 2 inches wide by 1 inch tall. That only tells us about this side of the object right here. By looking at the isometric view in the dimensions, we can see that this side of the object is 1 inch wide. The way that we know how tall it is by using our logical skills to infer that this 1 inch this 1 inch height goes from this baseline to this top line. So assuming that this base and this base are at the same level, we know that this height and this height are at the same level. And that's how we know that this is also 1 inch tall. So what I'm going to be asking you to do is to present 3 sides of a given object using flat views. So I'm going to ask you for the front, the side, and the top. And you have to imagine yourself looking directly at these sides of the object and representing them to scale, which means using the correct dimensions so that somebody else could see your 3 views and fabricate this object. So let's start with the top view. We know that the top view is 2 inches this way and 1 inch this way. So we're going to draw it this way. That's 2 inches wide by 1 inch tall. So we're going to line that up, drop down 1 inch, make that little line. And one nice thing about having drawn the border is I can use my border to line up my ruler. I have a translucent ruler, so I can see where the line lines up with the ruler. But if you don't, you could just move your drawing over a little bit and use that border or even the edge of your paper in order to make your lines perfectly vertical and horizontal. Now that I've done that, I can come over here and do the same thing. Start with 2, line it up so that it's parallel. And there's my 2 inch mark. I now have my top view. Next, I want to draw the side view. I can save myself a lot of work, and I will, by not measuring it again. Instead, what I'm going to do is I'm going to go from here, because I know this is the left side of the top view, and I know that this edge is at the same point as this edge, right? If you were to look at it from the top, you wouldn't even see this line because it's coming towards you. But if you look at the side, it's that same line. It's this corner right here, right? So you know that this corner is here on the side view. So what you're going to do is you're just going to take this line and you're going to drop it down like that. And that way you don't have to measure where it goes again. And the other thing, you're going to do the same thing with this side. Just like that. And like magic, you will have a 2 inch wide side view all ready to go down here. I want you to do it this way because what's going to happen is it's going to line up perfectly and it's going to be much easier to read once you have all your views lined up nicely. You know that the side view is 1 inch high because the dimensions tell you it is. So we're going to start from here, go up 1 inch, and make that nice and parallel, just like that. And let's label everything. Again, all capital letters, all done using these guidelines. So now what I can do is I can go over here and draw the front view. The front view shares this edge with the side view, just as the side view shares this edge with the top view. This edge between the top and side, this edge between the side and front. So we're kind of going around the corner, and now we're looking at it as if from here. We're going to go ahead and borrow this bottom line at the same level from the side view by simply bringing it across, lining it up, and bringing it across with our ruler. Same thing with the top. Line it up, bring it across with our ruler. Now we know that the front view is this high, and all we have to do is measure the width, which is given to us in the dimensions, 1 inch, right? So here's 1 inch wide, And we're going to just go ahead and make sure we get a good 90-degree angle there. A right angle. Now we have our front view, which of course we will label. And let's go ahead and make those labels line up to make it even nicer. Line up from there. Front view. Now, in order to tell our fabricator what size these need to be, we need to dimension them. So in order to dimension a view, you're going to simply extend some lines from the edge of your drawing. And basically do it like this. These lines are going to be lighter than the lines that you use for your drawing, because you don't want to confuse somebody by making them think that your dimensioning lines are the lines of your drawing. You want it to be very clear that what you are doing is telling them how big the object is. So we're going to go ahead and just darken the lines on our drawing so that there can be absolutely no mistake later on. And before you write your dimensions, you're going to write your guidelines. Right? This is 1 inch, and this is 2 inches. And the really fun part for me is adding the little arrows. Sometimes you might just see little slashes, but I like doing the little arrows like this too. Since we've dimensioned the top view, we have now told the person looking at this drawing that this, see, we dimensioned this edge. We told them that this is 1 inch, right? We told them there. And we told them that this edge is 2 inches. So normally, if you were already given dimensions in your isometric, you're going to want to just use the isometric definitions of the dimensions. So if you were doing this drawing, you wouldn't have to dimension this. You could go to the side and dimension the same places on the side view that are given in the isometric. And you could give them the front view. Generally, when you're dimensioning a drawing, you want to use the fewest number of dimensions necessary in order to convey the most amount of information about the dimensions of the object. So you can go through each dimension and think, okay, what do we not know about the size of this? When you have a three-dimensional object with only 6 faces on it, right? 1, 2, 3, and the ones that are opposite these 3, you only need to know 3 dimensions. You need to know the height, the width, and the depth. Or because we call this the front, this is the width, this is the height, and this is the depth. So as long as those 3 dimensions are given somewhere, you have enough information on your drawing. You can give 2 of them in one view and 1 of them in the other view. This gives you too many dimensions as it is drawn right now. I don't need to know that the top is 1 inch deep and 2 inches wide because I know that the side view is 2 inches wide and the front view is 2 inches wide. So that tells me the dimensions of the top view. And if you look at the dimensions and compare them to the isometric, all that will make sense. Here's a technical drawing. This is complete. You have your isometric view here, your top, side, and front view. They are lined up. And because they are lined up, you don't need to repeat the dimensions. I know that this is 1 inch high because I can see that it lines up with this view. All the text is written clearly in all capital letters. All the information I'm asking for has been given to me. In all cases, I use straight lines and I measured with a ruler. And it didn't take me very long. This would be a complete technical drawing. And what I'm going to do is I'm going to ask you to do a series of these, and they are going to get sequentially more complicated. I am going to give you the isometric view, and you are going to have to figure out the top, side, and front views. You are going to have to use all these tools in order to do those drawings. They are going to get gradually harder each time because I will add one element or take away an element from the isometric view. Every time I'm probably going to start with something that looks like a brick, and I'm going to gradually carve out more pieces. And you're going to have to figure out what the top, side, and front views look like. And you're going to have to create your whole technical drawing from scratch using a ruler, a pencil, an eraser, and a piece of paper.